So hello everyone and welcome to this next lecture on Python Power Electronics, and this is a part of the control series lectures. So this will be part 2 where I'm going to be talking about variable storage elements. So as before, I'll first start off by going to my circuit simulator website. So just Google Python Power Electronics and I get the first link as Python Power Electronics. So as I said before, I am going to start with the paper. So for that you come to the download section and you come to the part where the button called papers. Within papers we are going to use this paper, that is control structure. It's a short paper on special variables. I think in the previous lecture I told you to read it, and even if you've not read it, I would suggest read it now, or at least have it open for immediate reference. So I'm going to continue. I had a brief look at this and I'm going to continue with this. So in this lecture I'm going to talk about, we talked about input before, there are several others. I'm going to jump in this lecture straight to variable storage, and I'm going to tell you what is the importance of variable storage and what do you achieve with variable storage. So now that we've had this, let me straight away go over to my command line, and as before we enter the virtual environment. This is whichever the directory which contains a virtual environment. I have to first activate my virtual environment. So now I'm in my virtual environment. Let me just do a check. Yes, it is. So as usual, I go into diode rectifier. This is where I had most of the stuff, and actually I don't have to go in here. I have to go into PPE web app. I have to actually run my circuit simulator. I have to launch the server. So to launch the server, all I have to do is do python manage.py run server. So if you have a doubt about this, please go to the previous lectures or just check out any of the lecture on how to install the circuit simulator in Windows or Linux, whichever it is that you're using, and you will find that this circuit simulator needs a migration, and it needs a make migration which sets up the database, and it needs a migrate which creates the database before you run this. So if you have a doubt, go to those lectures. This shows everything is okay and the server is up and running. So I will go to this site, that is 127.0.1:8000. And as always, do not forget 8000. Like for example, if I take out 8000, I get something else. Okay, so do not forget 8000. This is your port. And if I have this, now I have my circuit simulator launched and running. So I go to my circuit simulation, that is my simulation library. I have only one simulation because I've been doing this so far. I've been only using this for all my tests. I load the simulation. I don't have to change any of these parameters, so I can just save it and go back to the main page. In add circuit file, again I'm not changing anything. This is just for your reference. It is a diode rectifier. That means it has a single phase source, it has a diode bridge, and it has a load. It has a load which consists of one static resistor and one resistor which has a switch in series. So it has one switch load and one constant load. So we are going to stick with this, nothing different. As before, when you're launching it for the first time, you have to say process circuit schematics. Nothing, no errors expected because everything is the same. So the circuit does not have any detectable errors, so we are good to go. Now I go back to the main page, and now here I come to edit circuit parameters. As always, this lecture is only on control, so I don't have to change any of these things. I only have to change the control parts. I'm just going through the steps so I reach there. So again, I go to main, and now I see there is an edit control option. So I click on edit control. Now in the previous lecture, I had already added switch control.py, and in switch control.py I had configured an input. So I'm now going to continue with this. I don't need another file, so I can just forget about it. At least this dialog box. So I'm going to go into configure control, and so now here I was. In the previous lecture, you will see that I added these three inputs. And after adding these three inputs, I now had showed you. Now let me go over to the code. For that, I'll just launch my Atom. So again, the editor is up to you. There are several. I also use Eric Python, but I use Atom also to quite a large extent to edit Python files. It's totally up to you. So yeah, Atom gives me pretty much exactly where I left off in the previous lecture. So I'm going to close these welcome guides and I'm going to come over here. So in the previous lecture, I had just written some dummy code and I had configured those three inputs. So those three inputs turn up in this reserved file called __ control.py. To know more about this, just read this file, this PDF file. This tells you more or less what happens, and in this you can see that all the control files that you write, they get embedded as control functions into this file called __ control.py. So this is a reserved word. This is a reserved file name. Do not name any of your control files as __ control.py. So this is my __ control.py, and in this I have these three inputs and I have my code. So now I will continue from here. So there are lots of things you can do, a lot of other variables, and I'll talk about them in future lectures, but I'm going to jump straight to this last one, that is variable storage. And the reason I'm doing this is because whenever you design a control, the most important thing you need to do, at least while you're developing your control, is to be able to debug the control. And in order to debug the control, what we use is called variable storage. And variable storage, as the name implies, means you can store a control variable, any variable, into the output data file. And once you are able to store it in the output data file, it will appear on the plots. So you can now plot it. So let me do that here. So I'm going to start off by adding a variable storage. Again, this is just trial and error. So we just scroll down. So similar to input, it has very similar things. So you say it has this desired variable name and control code. What this means is, this means what is the name with which you want to use it in the control code. If you assign any value to this variable, that variable will be written to the output data file. And I'm going to show you this. So let me say store var1, just a variable name, and initial value of variable I can give it 0, 0.0. Now this is very important. Storage status. Storage status is by default no. Storage status means, do you want to store this variable in the output file? And when we are using it as variable storage, we would like to store it. This variable, and I'm going to tell you why this option is given, because variable storage will also play another role, and I'll tell you that in some other lecture, in a future lecture, where I'm going to tell you how variable storage elements can be used to connect different control files together, but that comes later. For now, the only purpose of these variable storage elements is to be able to save any control variable in the output data file. So therefore storage status has to be yes. So now that we are done with this, let us click save variable storage, and we have one. So just for the fun of it, let's add another variable storage. So we have to scroll down, and let me call this store var2. Let's give it some value, 10.0. Let's give it some, it can be anything. This is just the initial value of the variable. It's usually sensible to have it 0.0, but in case you don't, you can always give it some other value. And as before, we want to plot this variable in the output data file, so you must say yes and click on save variable storage. So now we have 3 inputs and we have 2 outputs. Alright, looks great. Now let's go back to this. Now go back to the main page. We have edited the control. Now let's go and view the output. Now we don't really care about the plots because we are just playing around with the controls for now. The plots will only matter when we actually have a well-developed control. So for now, let's just run this. And it says simulation is running. Just always, whenever you run the simulation, come over here and check if there's an error. There is no error, so we are okay. Now let me now close that file and open it again. Okay, and you see what's happened? It has changed. The file has changed from the previous values, and this is what has happened. The 3 inputs are there as usual, and after that there are these two control storage variables. You see what's happened? Store var1 and store var2. These were the 2 variable storage elements that we just defined, and you see what's happening? They are being fetched from an internal variable store. Alright, this is an this is an internal variable of the circuit simulator. Don't try to change it. This is also an internal variable of the storage. So you see, every variable that you give a certain name, that is stored as a dictionary inside an internal variable in the circuit simulator. So in the beginning of every function, we are extracting the variable, that value that exists, assigning it to the variable name that we want, and this is now available in this circuit simulator. So I could do anything else I want here, and I'll show you that. And at the end, I do the reverse process, which means I take the value of these control storage variables, alright, because I'm assuming they would have been updated here. I would take these values and I store it back into the internal variables of the circuit. See, this is the internal variable of the circuit simulator. So you see, it's a reverse process. First, the circuit simulator gives the previous value that was already there, and then at the end of the function, it takes whatever changes you might have made and updates it back into the internal variable. So this way, the circuit simulator always knows the latest value of the variable storage element. So now that we have this, let me close this file and let me stop the simulation. And I'm going to show you now how we can use it. So as I said before, that variable name exists. So store var1 and store var2 are now available for me to use in my control function. Why? Because I have defined these 2 variables. Alright, I have defined these 2 variables. The simulator provides me with the previous value and the previous value in the previous iteration instant, and that value is now available to me. So 1, I could give it a new value. So for example, let me say, what is my, let me give you a better example of what I'm trying to do. Let's go back to the main page and let me go to edit control. Let me go to configure control. So let me say that I have voltmeter source 1 and voltmeter Vout. So let's say I'm going to give, or let's say ammeter source 1. So I'm going to take ammeter source 1, that is I source 1, and I'm going to assign some value. So let me do some dummy calculation, doesn't matter. So I'm going to say I source 1. Why? Because this is the variable that holds the meter current, the current measured by the ammeter. So I have this variable. So I could do something like multiplied by 2. Okay, and here I can do anything else I want, so no problem. So what do? Let's say I want to take the difference of these 2 voltages. Alright, there's nothing wrong. I can do anything I want. It's my own control code, so no problem. So I say Vout1 and V source 1. So let me do this. Vout1 minus V source. Okay, so these are just very simple examples. In reality, you can have a PI controller, you can do deadbeat control, you can do some very complex controls, and I can show you these things in some other lecture. For now, this purpose, okay, there's a spelling mistake here. Make sure the spellings are right, otherwise it'll give you a function error. Actually, you know what, later I can show you the error. So now that we have this much, let me save this and we go back and run the file. So I go back to control main, go back to the main page, go back to view output, and I run my control file. So it says simulation is running. Always go to the command line and check if there's an error. There is no error message, so everything's okay. So now that we have this, let us go and check this underscore control.py. You see what's happened? It has taken this control code and it has plugged it in exactly as it is. Alright, that's all it does. It just takes this control code and plugs it into this file underscore underscore control.py. So you might think what actually is going on. What is going on now is I can now plot these two variables, and let me now show you that. So let me now add another plot, and let me call this var store 1, because that's what I'm doing. I'm checking out variable storage 1, add waveform. So in the add waveform, before there were only 3 meters, the ammeter, the voltmeter, the source meter, that's it. And now you see, well, there were 4 meters. Now there are 2 more variables. You see this, store var1, store var2. Why? Because I have created these 2 control variable storage elements and I have designated them to be stored. Alright, they will now, by saying yes to the storage status, these will be stored in the output data file. And because they are stored in the output data file, they are now available to me as plotting elements. So let's plot it. So let's call this var1 and let's save waveform. Okay, let me just check out what it is. I don't want to add any more. Let's plot this. And let me plot what it is. Let me go into virtual length, let me go into diode rectifier, and you see there is var store 1. So it has now plotted this well. No, there is something else. To know what it is actually doing, let us now compare this, because if you look at this file, I am now taking var store, I am multiplying var store iSource by 2. So let's compare it by iSource to know what it is. Let me add another plot, or let me just delete this plot. So I'll just delete this plot and let me add another plot. Let me call it again var store 1. Doesn't matter. So let's just call it start plot, add waveform. Okay, let's add iSource 1. So I shall call this iSource 1, save waveform, add waveform, and let me now store var1. So I am storing store var1 and comparing it with iSource 1. The reason, because store var1 is twice the value of iSource 1. Let's confirm that. And let me do this, save this value. So there are 2 waveforms in this. And let me save this plot and let me plot this. So we have var store 1. It's not very clear, so I need to zoom. So let me zoom between 0.01 and 0.12, 0.10 and 0.12. I'm going to plot, zoom in between these things so that I can see exactly how these 2 variables are related to each other. And you see, now I have the zoom value, and if you compare, you see exactly as it is. var1 is the orange line, iSource 1 is the blue line, and the orange line is exactly twice the value of the blue line. So in this way, we can debug our control variables. Now in this particular example, it doesn't make any difference. It doesn't make any sense at all. But what I'm trying to show you through this video is you can have complex control structures inside this. And if you want to debug them, for example, let's say you want to know, and I'll be showing you this soon, is in how you want to debug your control philosophy, or you want to develop your control philosophy, you can check every variable and to see that it is okay before you actually connect it to the output. And in this example, I'm going to do that. I'm just first showing you how you debug it. So this is one. The next one, let's also plot the other one. And as before, let me call this var store 2 start plot and add waveform. Now here I am taking the difference of V out and V source. So let me plot these two. So there's V out. Let me add another waveform. V source 1. Actually, these names can be anything. They don't have to be the same as these names. These are the legend names. All right, they only appear in that graph. They are the names of those legends. It can be anything you want. So they don't have to be unique. They don't have to make any sense either. And I'm going to add the last one, and that is the actual storage variable. That is store var2, and let me call this var2. So now I have stored these two values. Let me save this plot, and as before, let me plot it. So this means it's busy. Now we're done. So now I have var store 2. So you see, this is another plot. Again, doesn't make much sense. We'll have to zoom in. So as before, let me zoom in between 0.2 and 0.24. I'm going to plot this variable again, and this time we get it. So you see what's happening. This is blue line is V out, the orange line is V source 1, and the green line is the difference of these two. Alright, it is the difference of these two. See, for example, here the peak is slightly smaller in magnitude than -200, so it's around -170 or so. This one, that is V out, is slightly lower than 200, so it's again around about 180. So now if I do -180 and -180, so it's around, this is positive 180, this is negative -180, it's basically double that, and that's what this is, 360. Alright, I'm doing V out minus V source. So this shows you how the control is. Let me go back and check what I've done. Yeah, I've done V out minus V source 1. So it's actually the other way. So it's the blue line minus the negative line. So it's 180 minus 180, which means 180 plus 180, that's 360. And that's what it is. So you see, this has now generated the difference of two inputs. Now, as time goes on, I'll show you how we can actually have several more variables and how we can generate much more intricate control, and how this variable storage elements can be used to debug and test our control as we develop it. So at this time, I'm going to stop this lecture, because as before, control is a huge series, and if I do it all in one, it'll be a very long lecture. I don't want to do that. So I'm going to stop this lecture now, and I will come back. The next lecture will be continuing with this. I'll probably continue with something like static variable. So continue watching this series to continue with the control variable, to get a good idea of how to write control functions in the circuit simulator. For now, this is where this lecture will end. So thank you so much for watching, and hope to see you soon. Goodbye for now, and keep watching for more lectures. Bye bye.